Module 5, Europe during the Middle Ages. Submitted by Rasul S. Sulaiman and Normala D. Muna. Introduction. With the 3rd century after Christ begins an era of migrations of nations in Europe. The powerful Goths quit their swamps and forests in north and sweep onward in steady southwestern current, dislodging the Vandals, Swedes, and Burgundians, crossing the Roman territory, and stopping and recoiling only when reaching the shores of Mediterranean. From the Oral Mountains, while the hordes sweep down on the Danube, the Roman Empire falls to pieces, and the Dark Ages begin. But dark though they seem, they are the germinating season of the institutions in nations of modern Europe. The Teutonic element, partly pure, partly intermixed with the Celtic and Latin, produces the strong and luxuriant growth in modern civilizations of Europe. Almost all the various nations of Europe belong to the Aryan stock, as the Greek and the Hindus. Both Aryan races were the great thinkers of antiquity. So the nations north of the Alps become the great intellectual leaders for modern times. So during this era, the Christ begins an migrations of nations in Europe, and the powerful Goths quit their swamps and they dislodges uh, their Vandals, Swedes, and Burgundians. So from the Oral Mountain, they sweep down the Danube. After that, the Roman Empire falls into pieces, and the Dark Ages begin. In this, the this is the germinating season of Europe institution. The Teutonic plate or Teutonic element is pure and intermixed with Celtic and Latin, and it produces strong and luxuriant growth, and that is the modern civilizations of Europe. And almost all the various nations of Europe are belong to Aryan stock. Aryan stock is a term originally used as ethnocultural self designations by Indo-Iranians in ancient times. As the Greeks and the Hindus, both Aryan races, were the great thinkers of antiquity. Uh, the greatest thinker of antiquity are Plato, Aristotle, Socrates, Einstein, and etc. So the nations north of the Alps become the greater intellectual leaders of modern times because of that greatest thinker of antiquity or the greatest leader of objectives. At the end of the topic, the students should be able to acquire knowledge of Roman mathematics and sketch the history of Middle Ages calculation mode of counting and of writing numbers. Lecture discussion.
Letter A, Introduction of Roman Mathematics. We shall now consider how these as yet barbaric nations of the north gradually came in possession of the intellectual treasures of antiquity. With the spread of Christianity, the Latin language was introduced not only in ecclesiastical but also in scientific and all important worldly transactions. Naturally, the science of the Middle Ages was drawn largely from Latin sources. In fact, during the earlier of these ages, Roman authors were the only can read in the Occident. Though Greek was not wholly unknown, yet before the 13th century, not a single Greek scientific work had been read or translated into Latin. Meager indeed was the science which could be gotten from Roman writers, and we must wait several centuries before substantial progress is made in mathematics. Meaning, Christianity was spread, the Latin language and ecclesiastical, but not only that, but also in scientific and all important words transaction. During this era, in the Occident, the only can read are those Roman authors. Greek was not wholly unknown before the 13th century, so not not a single Greek scientific work had been read or translated into Latin.
So, after the time of Boëthius and Cassiodorus, mathematical activity in Italy died out. The first slender blossom of science among tribes that came from the north was encyclopedia entitled Origins, written by Isidorus. This work is modeled after the Roman encyclopedias of Marcianus Capilla of Carthage and of Cassiodorus. Part of it is devoted to the quadrivium, arithmetic, music, geometry, and astronomy. He gives definitions and grammatical explications of technical terms, but does not describe the modes of computation then in vogue. After Isidorus, there follow a century of darkness, which is at last dissipated by the appearance of Vade the Venerable, the most learned man of his time. He was a native of Ireland, then the home of learning in the Occident. His works contain treatises on the computus, or the computation of Easter time, and on finger reckoning. It appears that a finger symbolism was then widely used for calculation. The correct determination of the time of Easter was a problem which in those days greatly agitated the church. It became desirable to have at least one monk at each monastery who could determine the day of religious festivals and could compute the calendar. Such determinations required some knowledge of arithmetic. Hence, we find that the art of calculating always found some little corner in the curriculum for the education of monks. So, the time of Boëthius and Cassiodorus, who are the 6th century Christian writers, helped preserve the heritage of Greek and Roman learning handed down by the generations of Christianity. They are the mathematical in Italy died out in the first slender of science blossom came from encyclopedia titled Origins. It was written by Isidorus, a native Egyptian priest who died 636 bishop as of Seville. These works modeled after Marcianus Capilla encyclopedia in his devotes are the quadrivium, arithmetic, music, geometry, and astronomy, and also gives meaning or definitions of grammatical explication of technical terms, but does not describe the modes of computation then in vague. After is the Darius, the follows of a century of darkness, which is at last dissipated by the appearance of Bede the Venerable. Bede the Venerable, also known as Saint Bede, the Venerable Bede, and he was an English Benedictine monk at the monastery of Saint Peter, in its companion monk monastery of Saint Paul in the kingdom of North Umbria of the angels, and he is also the most learned man of his time.
The year in which Bede died is also the year in which Alcuin, 735 to 804, was born. Alcuin was educated in Ireland and was called to the court of Charlemagne to direct the progress of education in the great Frankish Empire. Charlemagne was a great patron of learning and of learned men. In the great sees and monasteries, he founded schools in which were taught psalms, writing, singing, computation or computus, and grammar. By computus was here meant probably not merely the determination of Easter time, but the art of computation in general. Exactly what modes of reckoning were then employed, we have no means of knowing. It is not likely that Alcuin was familiar with the species of Boethius or with the Roman method of reckoning on the abacus. He belongs to that long list of scholars who dragged the theory of numbers into theology. Thus, the number of beings created by God, who created all things well, is 6. Because 6 is a perfect number, the sum of its divisors, which 1 plus 2 plus 3 equal to 6. 8, on the other hand, is an imperfect number. 1 plus 2 plus 4 is less than 8. Hence, the second origin of mankind emanated from the number 8, which in the number of souls said to have been in Noah's Ark. When Bede died, Alcuin was born in the same year. Alcuin was educated in Ireland, and he was called in the court of Charlemagne to direct the progress of education in Great Frankish Empire. Si Charlemagne ay isang patron or a great patron of in terms of learning and of learned men. So he found schools where the psalms, writing, singing, computation or computus and grammar were taught. Computus or computation was their meant or her meant. So what they are determined for is the art of computation and in general. So si Alcuin was not familiar with the species of Boethius or with the Roman method of reckoning on the abacus. So ang abacus, we will tackle that on the next reporter. So kasama siya sa listahan ng mga scholars who dragged that theory of numbers into theology. For him, the number of the beings created by God or who created all things well is 6. Kasi daw yung 6 is a perfect number because when you add that of its divisors, which 1 plus 2 plus 3 is equals to 6. And sa kanya, so the second origin of mankind emanated from the number 8. Because number 8 is not perfect number or imperfect number, because when you add 1 plus 2 plus 4 is less than 8. 8, which is the sum of souls said to have been in Noah's Ark.
So that is the collection of problems for quickening the mind. Propositiones ad Aquitius Juvenis, which are certainly as old as 1000 AD and possibly older. So Cantor is their opinion that they were written earlier by Alcuin, who is educated in Ireland. The following is a specimen of the problems. A dog chasing a rabbit, which has a start of 150 feet, jumps 9 feet every time the rabbit jumps 7 feet. In order to determine in how many leaps the dog overtakes the rabbit, 150 is to be divided or should be divided into 2. In this collection of problems, the areas of rectangular and quadrangular pieces of land are found by the same formulas of approximations as those used by Egyptians and given by Boetius in his geometry. An old problem is the cistern problem, given the time in which several pipes can fill a cistern singly. To find the time in which they fill it jointly, which has been found previously in Heron. In the Greek anthology and in Hindu works, many of the problems shows that the collections was compiled from the Roman sources. The problem, which on account of its uniqueness gives the most positive testimony regarding the Roman origin, is that on the interpretation of a will in a case where twins are born. The problem is identical when the Roman except the different ratios are chosen of the exercises for recreation. We mention the one of the wolf, the goat, and cabbage. To be rowed across a river in a boat holding only one besides and the ferryman. Query, how must he carry them across so that the goat should not eat the cabbage, nor the wolf the goat? So, the solution of the problem or problems for quickening the mind require no further knowledge than the recollection of some few formulas used in surveying. The ability to solve linear equations and to perform the four fundamental operations with integers. Extractions of roots was nowhere demanded, fractions hardly even occur.
The great empire of Charlie Magny tortured and fell almost immediately after his death. War and confusion ensued. Scientific pursuits were abandoned, not to be resumed until the close of the 10th century, when under Saxon rule in Germany and Capetian in France, more peaceful science began. The thick gloom of ignorance commenced to disappear. The zeal with which the study of mathematics was now taken up by the monks is due principally to the energy and eloquence of one man, Gerbert. He was born in Aureliac in Auvergne. After receiving a monastic education, he engaged in study of mathematics in Spain. On his return, he taught school at Reims for 10 years and became distinguished for his profound scholarship by King Otho I. And his successor Gerbert was held in highest esteem. He was elected bishop of Reims, then of Ravenna, and finally was made pope under the name of Sylvester II. By his former pupil, Emperor Otho III, he died in 1003. After a life intricately involved in many political and ecclesiastical quarrels. Such was the career of the greatest mathematician of the 10th century in Europe. By his contemporaries, his mathematical knowledge was considered wonderful. Many even accused him of criminal intercourse with evil spirits, meaning the great empire of Charlie Magny tortured or forgotten, meaning what we say, kinalimutan na nila sa kanyang pagpanaw. War and confusion ensued. Then scientific pursuit were abandoned. Then until the close of 10th century, then they resumed it. When under Saxon rule in Germany and Capuchin in France, more peaceful began times. So our times began. The thick gloom of ignorance commenced to disappear. So si Gerbert is isang monks which is hilig niya mag-aral ng mathematics. So siya ay pinanganak sa Aureliac in Auvergne. So after receiving a monastic education, he engaged in study of mathematics in Spain. So on his return sa kaning pagbalik, so nagturo siya sa school at ng Reims 14 years and became distinguished for his profound scholarship by King Otto I. Gerbert also elected bishop of Reims, then of Ravenna, and finally was made pope under the name of Sylvester II. By his former pupil, Emperor Otho III, so siya ay namatay sa taong 1003 after a life intricately involved of many political and ecclesiastical quarrels. So ayun. So na-involved din siya sa politics and ecclesiastical quarrels. Such was the career of the greatest mathematician of the 10th century in Europe. So Karamihan din sa sa panahong yun ay inaakusahan siyang criminal intercourse with evil spirits.
So, Gerbert enlarged the stock of his knowledge by procuring copies of rare books. Those in Mantua, he found the geometry of Boëthius. Though this is of small scientific value, yet it is of great importance in history. It was at that time the only book from which European scholars could learn the elements of geometry. Gerbert studied it with zeal, and it is generally believed himself to be the author of geometry. H. Wissenborn denies his authorship and claims that the book in question consists of three parts which cannot came from one and the only same author. This geometry contains nothing more than the one of Boëthius, but the fact that occasional errors in the latter are herein corrected shows that the author had mastered the subject. The first mathematical paper of the Middle Ages which deserves this name, says Hankel, is a letter of Gerbert to Adalbold, Bishop of Utrecht, in which is explained the reason why the area of a triangle obtained geometrically by taking the product of the base by half its altitude differ from the area calculated arithmetically according to the formula 1 over 2 a multiplied by a plus 1 used by the surveyors, where a stands for a side of equilateral triangle. He gives the correct explanation that in the letter divided are counted and wholly even though parts of them project beyond it. So Gilbert enlarges his knowledge just procuring copies of rare books. Then, thus in Mantua, he found the geometry of Boëthius. Maybe this book is a small scientific values, but it's very important in history. And this is also or that the only book in Europe people can learn the element of geometry. Gerbert studied this book and he believed that he is the author of this geometry. But H. Wissenborn denies the authorship of Gerbert. And Wissenborn claims that the books in question of three parts, and he believes it cannot be from in one author only. This geometry contains nothing more than one of Boëthius. But the fact that occasional errors in latter are herein corrected shows that the author had mastered the subject. The first mathematical paper of Middle Ages, which deserves name, says Hankel. Hankel is the letter of Gerbert and proof that he is the author of the book, in which is explain the reason why the uh, the area of triangle obtained geometrically according to the formula 1 over 2 or divided by 2 a multiplied by a plus 1 used by surveyors, whereas stands for a side of an equilateral triangle. He gives the correct explanation that in the latter formula all the small squares in which the triangle is supposed to be divided or supposed to be divided are counted and wholly, even though parts of them project beyond it.
Gerbert made a careful study of arithmetical works of both views. He himself published two works, Rule of Computation on the Abacus, a small book on the division of numbers. They gave an insight into the methods of calculation practiced in Europe before the introduction of the Hindu numerals. Gerbert used the abacus, which was probably unknown to Alcuin. Bernardinus, a pupil of Gerbert, describes it as consisting of a smooth board upon which geometricians were accustomed to strew blue sand and then to draw their diagrams. The early rules for division appear to have been framed to satisfy the following three conditions. Number one, the use of the multiplication table shall be restricted as far as possible. At least it shall never be required to multiply mentally a figure of two digits by another of one digit. Number two, subtraction shall be avoided as much as possible and replaced by additions. Number three, the operation shall proceed in a purely mechanical way without requiring trials. That it should be necessary to make such conditions seems strange to us. By it must be remembered that the monks of the Middle Ages did not attend school during childhood and learn the multiplication table while the memory was fresh. Gerbert's rules for division are the oldest extant. They are so brief as to very obscure to the uninitiated. They were probably intended simply to aid the memory by calling the mind to mind the successive steps in the works. In later manuscripts, they are stated more fully. In dividing any numbers by another of one digit, say 668 by 6, divisor was the first increased to 10 by adding 4.
The process is exhibited in adjoining figure. As it continues, we must imagine the digits which are crossed out to be erased and then replaced by the ones beneath. It is as follows: 600 divided by 10 is equals 60. But to certify the error, 4 times 60 or 240 must be added. 200 divided by 10 is equals 20. But 4 times 20 or 80 must be added. We now write for 60 plus 40 plus 80, it's sum 180. 80 divided by 10, 180, and continue thus. 100 divided by 10, then correction necessary is 4 times 10 or 40, which added to 80 gives 120. Now 100 divided by 10 is equals 10, and the correction 4 times 10 together with the 20 gives 60. Proceeding as before, 60 divided by 10 is equal 6. The correction is 4 times 6 is equals 24. Now, 20 divided by 10 is equals 2. The correction being 4 times 2 is equals 8. In the column of units, we have now 8 plus 4 plus 8 or 20. As before, 20 divided by 10 is equals 2. The correction is 2 times 4 is equals to 8, which is not divisible by 10, but only by 6, giving the quotient 1 and the remainder 2. All the partial quotients taken together give 60 plus 20 plus 10 plus 10 plus 6 plus 2 plus 2 and plus 1 is equal 111. And the remainder 2, similar but complicated, is the process when the divisor contains 2 or more digits, where the divisor 27. Then the next higher multiple of 10 or 30 would be taken for the divisor, but corrections would be required for 3. He who has the patience to carry such a division through to the end will understand why it has been said of Gerbert, the regular did it, quia sadutibus abasis fix intelliguntur. He will also perceive why the Arabic method of division, when first introduced, was called the divisio aurea, but the one on the perceive why the Arabic the one on the perceive abacus, the divisio feria. In this book on the abacus, Bernilinus devotes a chapter to fractions. These are, of course, the duodecimals first used by the Romans. For want of the suitable notation, calculation with them was exceedingly difficult. It would be so even to us, were we accustomed, like the early Abbasists, to express them not by numerator or denominator, but by the applications of names such as Ansia for 1/12, Quansicuns for 5/12, Dodorans for 9/12, and the 10th century. Gerbert was the central figure among the learned. In his time, the Occident came into secure positions of all mathematical knowledge of the Romans. During the 11th century, it was studied assiduously, though numerous works were written in arithmetic and geometry. Mathematical knowledge in the Occident was still very significant. Scanty indeed were the mathematical treasures obtained from Roman sources. So that's the end of our topic, and we want to apologize if we didn't explain it very well. Thank you very much for watching and listening.